In this short video, I'm going to talk about how to solve one-step and two-step algebraic equations. You can see that what I've done is I have four different equations here. I have one that deals with addition, one that deals with subtraction, one that deals with multiplication, and one that deals with division. All four of these equations are really easy to solve. That's not the point of what the actual answer is, because you can probably just give the answers in your head. But what I think is important is going through the correct process of showing what you are doing each time, because when you get to more complicated problems, it'll be important to show that particular process in order to get the correct answer. When solving these equations, there are all sorts of different ways that different books and videos show you how to do it, so I'm going to show you my particular way, but there are certainly other ways to go through and do it. For the very first equation, x plus 4 is equal to 8. In order to solve this, you always want to get the variable, in this case x, by itself on one side of the equation. Right now it's x plus 4, so I'm going to do the opposite and I'm going to subtract 4 from that side. If I subtract 4 from that side, I also have to subtract 4 from the other side. And that is the big rule of solving equations. Whatever you do to one side, you have to do exactly the same thing to the other side. So I just showed what I am going to be doing to both sides, and now I'm just going to simplify both sides. On the left-hand side, I'm just left with x. On the right-hand side, I have x is equal to 4 for my final answer. The nice thing about solving equations is that you can always take your answer, in this case x is equal to 4, put it back into the original equation and just check to make sure that it does work. And obviously 4 plus 4 does equal 8. In the second equation that I have here, y subtract 5 is equal to negative 12. My variable y, I am subtracting 5. So I'm going to add 5 to that side to get rid of that subtract 5. Whatever I do to the left-hand side, I have to do to the right-hand side. So now I'm going to simplify both sides. On the left-hand side, I have y. On the right-hand side, negative 12 plus 5 gives me a negative 7. And negative 7 subtract 5, if I put negative 7 back into the original, negative 7 subtract 5 more does give me an answer of negative 12. The third equation that I have listed, 3x is equal to 18, that's actually a multiplication. Anytime at all that you have a constant, 3 in this particular case, followed directly by a variable, it's understood to be multiplication. So this is 3 times x. So what I'm going to do is I am going to divide both sides by 3. And I'm going to show that this particular way. And then, in order to go through and figure out that answer, this is 3 times x divided by 3. 3 divided by 3 just gives me 1. So I'm left with x is equal to 6 for the final answer. In the last example that I have here, x divided by 3 is equal to 6. Since I'm dividing by 3, now what I need to do is I need to go through and I need to multiply both sides by 3. So I'm going to show that in that particular process. Once I do that, then this is x divided by 3, but I'm multiplying it by 3. So the 3 divided by 3 just gives me 1. So I'm just left with x, and on the right-hand side I have 18. So once again, I can go through and check and make sure that that does work, and certainly 18 divided by 3 does equal 6. As I said at the beginning, these are all one-step algebraic equations and are very easy to solve. It's just that the process will show you how to go through and solve these, so that when we do get into the more complicated problems, knowing the process should be helpful. Solving two-step algebraic equations means that you have two different operations associated with the x in the equation. In the very first equation I have listed here, 6x plus 3 is equal to 15, I am multiplying, which I'm going to show with a dot because that is an understood way of showing multiplication with algebra, and you also have addition. In the second equation that I have here, y divided by 5 subtract 3 is equal to 7. The two different operations that I have are divide and subtract. In both of these, once again, I want to get the x all by itself on one side of the equation. And if you have a combination of multiplication and addition, you always will get rid of the addition first. So the very first thing I'm going to do is I'm going to subtract 3 from both sides. If I subtract 3 from both sides and then simplify each side, I now have 6 is equal to 12. Now I'm down to a one-step type problem. So now what I'm going to do is I am going to divide both sides by 6. When I divide both sides by 6, the 6 divided by 6 gives me 1. So I'm just left on the left-hand side with x, and on the right-hand side I'm left with 2. So x is equal to 2. Once again, if I take the answer 2 and put it back up into x into the original equation, I do have to get both sides to be equal to each other, and you can see that 6 times 2 is 12 plus 3 does give me 15, so I was able to go through and solve that. On the second equation that I have, y divided by 5 subtract 3 is equal to 7, the very first operation I am going to be getting rid of is I'm going to be getting rid of the subtract 3. So I'm going to add 3 once again to both sides. If I add 3 to both sides, on the left-hand side I'm just left with y divided by 5. On the right-hand side I'm left with 10. So now I'm once again down to a single-step equation, y divided by 5. In order to get rid of that division by 5, I am going to multiply both sides by 5. So if I multiply both sides by 5, now those two 5s, it's 5 divided by 5 equals 1. I'm just left with y. And on the right-hand side, I'm left with 50. And certainly if I take that 50 and put it back into y in the original equation, 50 divided by 5 does give me 10. 10 subtract 3 does give me 7. So it does work. Sometimes you may get an algebraic equation that looks a lot longer, but it really follows the same way of doing things. It's just a third step or possibly even a fourth step. In this particular equation, before I would go through and do anything from subtracting or adding from one side or the other side, I see some things that I could go through and I could combine. In other words, I can simplify something in this equation. So when I do that, I see I have a 6x and I have a 3x, and I can certainly simplify those, and 6x plus 3x is equal to 9x. And then I see that I also have a 5, but it's understood to be a negative 5 because of the subtraction sign in front of it, and a 4. So I have negative 5 plus 4. Negative 5 plus 4 gives me 1 for an answer. So all I did first is I just went through and I simplified the left-hand side. Certainly when starting with algebraic equations, if you can simplify either one of the two sides to start with, you certainly want to go through that process. Now I'm just down to my two-step process, so I can go through and I can just add 1 to both sides. If I add 1 to both sides, on the left-hand side I'm just going to be left with 9x. On the right-hand side I'm going to be left with 9. And now I'm going to go through and I'm going to divide both sides by 9. So I get a final answer of x is equal to 1. And I can go back into either one. I could actually go back up all the way up to the very top, and I could check and make sure that it would work, and it would. Or I could go into the second equation and check and make sure it works there. The only problem with that is if I made a mistake as I simplified things from the first to the second when I was doing that, that could cause a problem when I'm going through and I am checking. Before going on to the next video in this module, I would like you to complete the quick check on this video, which can be found next. If you do well in the quick check, you may be ready to watch the next video. If you have difficulty with it or just want to continue to review the material, there is also a supplementary set of problems you can do for practice, as well as links to some different websites. You can also get in touch with me directly so I can help. Thank you.